students, and welcome to the continuing lesson on differentiability. And now we're going to take a look at derivatives from the left side and from the right side. Okay, so this is a derivative from the right. And so in some cases, you may have a function where, let's say you have something like this. Let's say that was your function, okay, where there's a sharp turn right here. So if we try to find let's say this point here, C, okay, so we may find that drawing the tangent line at this point may produce this result. Okay. So we don't necessarily know what the derivative is, but we want to find out what happens to the slope of the tangent line. So I can draw a bunch of tangent line here. So here it looks like that. Here it starts to level out more. As I get closer and closer, the tangent lines change a little bit, and then at this point, coming from the right, I end up with this line right here, and whatever the slope is, that's the derivative coming from the right at the point C. Okay. Now this is a nice distinction because you may get a different result coming from the left. So if I try to draw just a bunch of tangent lines here coming from the left, as I get closer and closer to this point, we get a closer and closer result. So here the red line, this red line right here, actually represents the instantaneous rate of change, or the derivative at the point C coming from the left. Okay? And I know this is a little bit of a weird function, but functions like this do occur in real life, and it's important to recognize that in this case, the derivative from the left and the derivative from the right, they are not necessarily the same. Okay? So let's make a note of that. We have a couple familiar notation now, coming to a point from the left, coming to a point near the right, and this here is just the difference quotient that we're used to. This is called the difference quotient. Okay, for a derivative, and I guess we can say this as well. It's also a difference quotient, and this here shows us something, that the derivative from one direction might not be the same as the derivative from the other direction. The important definition we have is that a function f is differentiable at C if the right-hand derivative is equal to the left-hand derivative at the point C. In this example from the previous page, we can see that whether we approach from the right or we approach from the left, you're going to have the same tangent line and the same slope for the tangent line. So this function is differentiable at this point. Over here, we have something that's a little bit different, where the derivative from one side, the right, the green arrow here, is actually a very different derivative, a different tangent line than coming from the left, which is this red arrow here. So this particular graph that I drew is not differentiable at C. It may be differentiable elsewhere, just not at that particular point. So a few notes to make here. First, wherever there are sharp turns, the function is generally not differentiable there. So I'll draw another example. So if you have something like this, where you have a sudden sharp turn at this point, it is not differentiable. Another prime example is like the absolute value function. This is not differentiable because coming from the right you have one tangent line, and coming from the left you have a different tangent line. Next, if you have a tangent line that is vertical, that would also mean that it is not differentiable. Okay? So if you had, some sort of graph where, say, you get something like this, and then suddenly it goes sharp, and it continues on, the fact that you have a vertical line right here, this is not differentiable, because the slope of that line is undefined. It's infinite. Okay? And then finally, wherever a graph is discontinuous, it is not differentiable. If a graph is not continuous somewhere, then it is not differentiable. Now, it could still be continuous and not differentiable. Okay, so in other words, continuity is a requirement for differentiability, but not the other way around. A function could still be continuous, like here, at 0 with the absolute value, but not be differentiable. But in order for something to be differentiable, it must be continuous at that particular point. So we've sort of laid the groundwork here for calculus, and particularly the derivative. Hopefully you get some sense of what it is and how it works. We'll continue to develop these ideas in the upcoming sections. Thank you for watching, and have a wonderful day.